Hi, good day. This is Alan Joshua Son from the College of Medical Laboratory Science, Our Lady of Fatima University Antipolo campus. I'm here to hand you the asynchronous activity for this afternoon. For the outline, we will be having the pre-laboratory discussion in which we're going to talk about a little bit of your SARS-CoV-2 and of course your polymerase chain reaction. And of course, I will be giving you guys later on your problem-solving activity. Before we talk of your SARS-CoV-2, hindi po ito yung kauna-unahang virus na nag-cause ng pandemic. If I may, in the past 10 years, ang dami na pong sakit na nag-emerge at nag-re-emerge dito sa Philippines. If I'm not mistaken, in year 2004, ladies and gentlemen, nauso si SARS na kung saan ang causative agent is the SARS-CoV virus. Sir Joshua, in 2009, sinundan ito ng AH1N1. Yung causative agent nito yung influenza virus. And in 2010, nagkaroon ng malaking outbreak ng dengue dito sa Philippines. In 2011, nakilala si chikungunya. Noong 2012 naman po, nagkaroon ng malaking outbreak ng leptospirosis. In 2013, you've had your pertussis and your measles. And in 2014 and 15, I think you guys are familiar with this. Kamag-anak ito ng SARS-CoV-2. Sino ito? Si MERS-CoV. Oo, MERS-CoV, yung Middle East Respiratory Coronavirus. Then you have your Zika in 2016, measles noong 2017 hanggang 2018, and 2019, December, up to now, you have your SARS-CoV-2. Walang magkakamali. Kasi pag sinabi mong SARS-CoV-2, ito yung sanhi ng Coronavirus Infectious Disease 2019. I have here a list of the different virus families that is known to cause disease in humans. And ladies and gentlemen, the SARS-CoV-2 belongs to the Coronaviridae family, which is an RNA virus family. Meron po tayong 7 strains na kilala na nagkakos ng infection sa tao under your Coronaviridae. And dalawa lang po sa mga strains na ito ang nagbibigay ng malalang sakit sa mga tao. Yung SARS-CoV-1 at yung MERS-CoV po natin. Ang SARS-CoV-2, hindi po ganun kalala ang binibigay na sakit. Ngunit kung ikaw ay immune compromised, matanda, o bata, medyo mataas ang chances na mag-develop ka ng severe na sintomas at mga senyales. Ang SARS-CoV-2 ay naiiba mula kay SARS-CoV-1 sa kadahilan ng una, ang SARS-CoV-1 po ay mas malala ang sakit na idinudulot at pangalawa, hindi po ganun kabilis maipasa ang SARS-CoV-1 kumpara kay SARS-CoV-2. SARS-CoV-2 originated in the province of Wuhan, China. And dito po naitala yung kauna-unahang human-to-human transmission ng SARS-CoV-2. But we all know that SARS-CoV-2 originally came from the bats at naitransmit na mga bats ang SARS-CoV-2 sa mga pangolins. Sir Joshua, paano napunta sa mga tao yan? Kasi ang Wuhan, China, sikat yung market nila doon na nagbebenta ng mga exotic na kahayupan at kinakain ng mga tao doon ang mga exotic na animal na ito. Sir Joshua, totoo ba yan? Yes po. Paano po ba, Sir Joshua, na ipapasa ang SARS-CoV-2 from one person to another? Number one, you have here the droplet transmission. Paano droplet transmission yan? Umubo ako, yung talsik ng laway mula sa ubo ko pwedeng masinghot nung katabi ko. Okay. Ganun pala siya. Kaya po tayo pinagmamask at pinagsusuot ng face shield. At kung mapapansin nyo, yung mga establishments na pinapasukan ninyo, may mga glass, ang tawag doon, sneeze guard. Then you have your fomites. Kaya po napaka-effective ng paghuhugas ng kamay. Kasi when you say fomites, say for example, ako, inubo ako, hinawakan ko yung aking bibig no ako'y umubo, tapos yung kamay ko, hinawak ko ng doorknob. Naku, yung doorknob contaminated na. Kapag ginamit yun yung sumunod sa akin, tapos pinunas niya sa kanyang mga mata, possible pong mahawa siya. That is via fomites. Fecal oral route, well, tanggalin natin ito. Alam po natin na ang SARS-CoV-2 pwede pong makita sa dumi ng tao. Pero, yung SARS-CoV-2 na makita sa dumi ng tao is already dead. Hindi na po kaya mag-transmit na infection yan. Bakit? Kasi ang SARS-CoV-2 super bilis niyang mapatay. And of course, you have the airborne transmission, pero hindi mo kailangan mag-worry dito dahil airborne transmission is only possible in enclosed environments. Example, hospital rooms, laboratories. Totoo, Sir Joshua. Yes po. So I have given you a little introduction with your SARS-CoV-2 because we're going to focus on testing the SARS-CoV-2. We have here the polymerase chain reaction. Polymerase chain reaction, ladies and gentlemen, is a technique to make millions of copies of a specific DNA region in vitro. When you say in vitro, ang literal na English translation nito is in glass. Pero in today's language, when you say in vitro, ibig sabihin in the laboratory. You do it in the laboratory. There are plenty of uses of PCR in the laboratory. It can aid in the detection of infectious diseases and it can be used in forensic science. For infectious diseases, ladies and gentlemen, PCR can be used to identify the following: viruses: HIV, hepatitis B, herpes viruses, your dengue viruses, influenza and other respiratory viruses, Ebola virus, your enterovirus and your poliovirus, and a whole lot more. For bacteria, ladies and gentlemen, you have your leptospirosis, which is caused by your Leptospira interrogans, your Neisseria infection, which is caused by your Neisseria gonorrhea. You have your tuberculosis, which is caused by your Mycobacterium tuberculosis. Cholera, which is caused by your Vibrio cholera. Then you have your anthrax, which is caused by your Bacillus anthracis. Aside from your viruses and your bacterial infections, it can also be used in detecting your parasitic infection. Example, your malaria. Malaria is caused by your Plasmodium species, Plasmodium vivax, Plasmodium ovale, Plasmodium falciparum, etc. You have your Capillaria, which is a nematode. Capillaria philippinensis is causes your capillariasis. Then you have your fungal infection, which is caused by your Histoplasma capsulatum and your Cryptococcus neoformans. Well, these latter two are usually seen in immune-compromised individuals. For forensic science, ang paggamit po ng PCR is super valuable because this may be used in DNA profiling, DNA typing, genetic fingerprinting, and DNA testing. Ooh, dito. Kung maalala po natin yung course na biology, I think you guys are so familiar with that course. Tama po ba na under meiosis and mitosis, meron tayong tinatawag na DNA replication or the nucleic acid replication? Yes, and it takes place inside your nucleus. Tama po ba yon? Yes. But Sir Joshua, so ang mangyari, di ba kapag nagre-replicate ang DNA o ang nucleic acid from single DNA strand, dumadami sila? Paano natin ginagawa yun sa laboratory? Kasi nakalagay dito, PCR mimics the DNA replication in vitro. Yes, Yun po yung principle ng polymerase chain reaction natin. Kasi maski isang pirasong DNA strand lang, yun nandun sa sample natin, paparamihin niya yan. Dito. Ano po ba, Sir Joshua, yung kauna-unahang step for PCR? Kailangan kunin natin yung nucleic acid na nasa loob ng ating cell. I have here a cell. How are we going to get this? We're going to lyse the cell para ma-liberate yung DNA. And yung DNA na yan, yung gagamitin natin for PCR, for the polymerase chain reaction. Meron kang isang pares ng DNA strand at pararamihin natin siya hanggang sumabot ito ng milyong-milyong kopya at pwede mo nang ma-detect gamit ang PCR machine mo. So before we will be able to proceed with the PCR testing, we first need to have the reagent. When you say reagent, it's a mixture of different chemical substances that will make the reaction possible later on for PCR testing. So as you can see, ladies and gentlemen, I have here what you call a master mix formula. Kasi kapag pinagsama mo na po itong dalawang ito, this reaction mix and this NCOV enzyme, this is what you call a master mix formula. So, sa isang well, kasi when you say well, yan yung butas na paglalagyan natin later on ng reagent at ng template natin. Ngayon, so sa isang well or sa isang reaction, kailangan natin ng 20 microliter. And sa 20 microliter na to, it's composed of your 18.5 microliter of your reaction mix and 1.5 microliter of your enzyme. Anong meron dito? So in order for you to know the total volume that you will be needing for a certain PCR reaction or certain PCR plate, you have to compute for the following. Number one, you have to determine the number of the patient samples for PCR testing. Ito siya. Say, for example, ladies and gentlemen, we have 18. We have 18 patient samples. So, 18 yung patient samples natin. Okay, lagay natin dyan. Then, for the number of controls, ang standard kasi, uniform yan, tatlo palagi. Okay? So, tatlo yung controls natin. You have your NTC, you have your positive and negative control. And for the pipetting error, ang pipetting error is yung allowance mo. Kung nagkamali ka, kung magkulang ka man, meron kang sobra. Okay? So, say for example, since tayo, medyo bago-bago pa lang tayo, magbigay tayo ng pipetting error na tatlo. So, pwede ka magkulang ng tatlong samples kasi meron kang extrang tatlo. Pero for those people na ang tagal ng ginagawa ito, hindi nila kailangan ng pipetting error. Okay? Kasi very precise and very accurate na yung pipetting skills nila. When you say pipetting skills, yung paggamit ng pipette. And when you say pipette, ito yung ginagamit natin instrument to transfer a small amount of liquid from one container to another. Okay? So we now have here 18 plus 3 plus 3. Kasi 18 yung samples natin, 3 yung controls, then we allotted 3 for pipetting error. Anong gagawin? We have to sum it all up. 18 plus 3, that is, naku, ang hirap naman dito. Bigyan nyo akong tatlong araw. Okay, 18 plus 3, that is 21 plus 3, you have a total of 24. 24 reactions ngayon. Or maglalagay tayo ng reaction mix, maglalagay tayo ng master mix sa 24 na wells. Okay? So ngayon, in order for us to know or to compute for the total volume of reaction mix that is going to be needed for 24 reactions, we just have to multiply this with this. Okay, so it's 24 multiplied by 18.5, you have 404 microliter. 404 microliter ng reaction mix. How about, Sir Joshua, for the NCOV enzyme? Same. You just have to multiply 24 by 1.5 microliter. So now, you have 36. Okay, so 444 plus 36, That's 480. Okay. So we are in need of 480. 480 volume of master mix to cater 24 reactions. Totoo? Yes. How are we going to check this, Sir Joshua? Uy, dito. 480 total volume. Sabi natin sa isang well or sa isang reaction, kailangan ng 20 microliter. So you just have to divide 480 with 20 at ang kailangang sagot na makuha mo is 24. Totoo po ba yun? Yes. Dito, check mo. 480 divided by 20, dapat 24 yan. Para ma-check mo kung tama yung computation mo. Again, kailangan sakto ito. And I'm telling you, I'm not talking about mils or milliliters. I'm not talking about liters. We're talking about microliters. Mas konti pa sa isang patak. Dapat dito walang labis, walang kulang. Totoo, Sir Joshua? Yes. Para maligtas ka sa mga ganyang kapamakan, meron tayong tinatawag na pipetting error, yung allowance mo. Okay? So, meron kang tatlo na allotted na extra para if ever man magkamali ka, meron kang tatlo. Okay? Remember, ang reagent po natin is really, really expensive. Magkamali ka sa computation na to, nako, 40,000, 50,000 yung sinayang mo. Lagot ka. Dito, dito. Ayun, sa previous slide, pinakita ko sa inyo kung paano tayo gumagawa ng master mix. And in this slide naman, I'm going to show you kung sino-sino yung composition or ano yung components ng reaction mix natin. Kasi marami pa siyang component. Bali, yung pinakita ko sa inyo in the previous slide, pinadali na yung buhay ni Medtech. But for this one, we're going to start from scratch because you have the different components of your reaction mix. So, ang gagawin natin dito, we're going to get here pipette. Ang pipette is an instrument that is used to transfer small volumes of liquid from one vial to another container. So, you have your molecular grade water, pipette that, and dispense it dun sa ating microcentrifuge tube. Ayan. Then you have your PCR buffer, pipette that, transfer it to your microcentrifuge tube. You have your magnesium chloride, you have your primers, you have your DNTPs, and then you have your polymerase. Ayan. So, napaghalo-halo na natin sila, no? Sir Joshua, are we going to start with a PCR? Well, not yet. Okay? You have to make sure, napaka-importanting step na to whenever you combine these substances. You have to vortex mix it. Okay? Hindi pwedeng ganyan siya na merong layers. Kailangan ma-homogenize yung reaction mix natin. Okay? Kapag na-homogenize na siya, you're good to go. That's what you call the PCR master mix. And now I have here the 96 well plate. Bakit tinawag na 96 well plate? Kasi yung butas na yan, yung mga bilog-bilog na yan, you call it wells. Okay? So magpapipe tayo dyan ng ilan? 20, di ba? 20 ang isang well. 20 microliter ang dapat laman ng isang well dito. So you have here your PCR master mix. Pipette tayo. Kuha tayo ng 20 UL. Dispense natin sa bawat butas na yan. Okay? Sir Joshua, sabi mo 96 yung butas na meron dito. 96 yung wells na meron tayo dito. Mapupuno ba natin to? Hindi po. Because remember, we only computed for 24 reactions or 24 wells. Tama po ba? So maglalagay tayo ng 20 microliter sa 20 wells na nandito sa 96 well plate po natin. Meron tayong tinatawag na template. Remember, napag-usapan po natin na ipakita ko sa inyo dun sa virtual tour natin sa isang molecular lab, yung reagent preparation room. And katabi ng reagent preparation room is the template addition. Ano yung template na yan? When you say template, yan po yung sample ng patient na merong RNA or DNA. Oo nga, sabi mo sa room number 4, sa template addition room, dito pinagsasama yung sample ni patient, and that's what you call your template, at yung reagent na pinipare mo mula sa room number 3. So you just have to pipette that template and transfer it doon sa well na may lamang reaction mix and enzyme mix or may lamang master mix. Okay? So you just have to pipette it. And now we're ready to load our sample doon sa ating PCR machine. O mapapansin mo, butas-butas siya, no? Yes. Kasi dyan po natin ilalagay yung 96 well plate po natin. Then afterwards, isasaral lang ito, then magra-run na po tayo. So as you can see, ladies and gentlemen, say for example, this is your PCR, yung itim na yan. Then ito pong nasa taas, that is your 96 well plate. Okay, so nilagay po natin doon sa may PCR, then mag-aantay lang tayo hanggang sa magbago-bago na yung temperature. Kapag nagbago na yung temperature, taas-baba yung temperature, the replication will now proceed. Ayan. So, from a single or double-stranded nucleic acid, dadami na sila hanggang sa dumami ng dumami hanggang sa pwede na siyang ma-detect ng PCR machine natin. Take note, ladies and gentlemen, that yung dumaming nucleic acid doon sa ating plate, doon sa 96 well plate natin, is not visible to the naked eye. Nakikita mo ba siya, Sir Joshua, ng microscope? Hindi rin po. Kaya gumagamit tayo ng machine. For SARS-CoV-2, ang gamit natin is a real-time PCR. Kaya pala Sir Joshua nakalagay palagi. RT-PCR swab test, mga ganun-ganon, di ba? RT, real-time. Okay? So Sir Joshua, ito, kaya siya tinawag na real-time is because hindi pa tapos yung reaction, nakikita mo na kung sino yung positive. Kasi usually merong 1.5 hour to 2 hours na waiting time para makita mo kung positive ang patient for SARS-CoV-2 or negative siya. Paano namin nalalaman? Di ba pinakita namin sa inyo sa video? Pinakita namin sa inyo sa video kapag may curve na umakyat ng ganun, nako positive, totoo ba yun? Yes po. Okay, so say for example, umakyat ng ganyan yung reaction well o yung well na yan, ibig sabihin positive siya. Pero kapag dire-diretso lang yung linya, that's negative. Okay? So yung pinapalagi namin pinagdadasal, kapag nasa PCR run kami, palaging flat line lang siyang ganyan. Kasi kapag may nag-amplify, naku, positive yung patient natin. Okay? Ayun. Now, for the laboratory activity, computation lang po tayo ng reagent. So I think you are already familiar with this since I've already shown you how to do this a while ago. So I have here problem number 1, the given. Patient samples, 93. Controls, 3. Pipetting error, 4. And we will be making use of this graph. Okay? So, ang reaction mix na kailangan mo is 18.5 and the enzyme mix is 1.5. Total of 20 microliter per reaction or per well. Solve this. Problem number 2. Given 45 samples, controls, 3, pipetting error, 2. Sir Joshua, ang dami namang composition ng master mix natin. Yes po. So you have to know kung gaano karaming nuclease-free water, universal probes reaction mix, primers probes mix, reverse transcriptase, and internal control template ang gagamitin mo per well. Kindly solve this. And then, for the last problem, kindly compute for the total volume of the master mix formula that will be needed for 8 samples ng patient, 3 controls, and 2 pipetting error. So please solve this. And that ends your activity. Maraming salamat po.